Hello, Senior 2. Now we are going to explain third lesson in our first unit about digestion. Okay, digestion or digestive system. Digestion, meaning of digestion is conversion of the polymer of food into monomer. So by conversion of polymer to monomer, this is meaning of digestion. Okay, types of polymers. We have three types of polymers, okay, essential polymers inside your food. First one, protein. Number two, carbohydrates. Number three, also we have lipids. After digestion, completely digestion, protein will change to amino acids, carbohydrates change to monosaccharides, and the last one, lipids, will change into fatty acids with glycerol. So our mission today to form or to change those polymers to monomers. Okay. First, we have two types of reactions inside your body. Okay, your reactions inside your body, total reactions inside body, okay, is named by metabolism. Metabolism, total reactions, bioreactions that occur inside your body, and we have two types of metabolism. First one, anabolism, and second one, catabolism. Meaning of anabolism, change from monomer to polymer, so for building. And catabolism, okay, change from polymer to monomer. For what? Common for produce energy. Okay, so we have here two types of reactions, anabolism and catabolism. Both of them, to be occurred inside your body, need enzyme. Yes, enzyme. You listened before about enzyme in Senior 1, and now I will remember you about enzyme. Enzyme work like catalyst, so it's work like catalyst, and enzyme, its mission accelerate the reaction. So its mission is acceleration of the speed of reaction. Okay, to enzyme complete its mission, okay, have a lot of limiting factors. The common limiting factors, number one, temperature, and temperature inside your body either stable 37. Number two, pH, and pH also inside your body different from part to another part, and you will see this during our mission inside your body. Number three, temperature, pH, and the amount of substrate, meaning of amount of substrate, amount of the polymer that enzyme will work on to be digested to monomer. So the amount here is very important. The work of enzyme, like a theory of lock and key. Lock and key, please careful here. This is enzyme, and any enzyme contain active site. This active site, okay, this is a a fixed point or fixed place on the surface of the enzyme that will recombine with the substrate. So this is a substrate. If the active site and the receptor of substrate and enzyme are same, okay, so the enzyme will work on the substrate. If not same, so the enzyme will not work on the substrate and they cannot perform its work efficiently. Okay, so the work of the enzyme depends on key and lock theory. Okay, lock and key theory. Digestive system. Digestive system start from mouth, then pharynx, esophagus, stomach, small intestine, large intestine, rectum, and finally anus. Mouth, pharynx, esophagus, stomach, small intestine, large intestine, rectum, and anus. All of them named by elementary canal. And elementary canal not work only but by associated accessory glands. So we have here associated accessory glands 3. Salivary glands, okay, liver, finally pancreas. So we have here a rule mission from mouth, last one to anus by the help of associated gland, salivary glands, liver, and pancreas. Now we are going to explain the digestion in each part during the alimentary canal by the help of associated gland. During your mission inside your body of digestive system, you will know the type of digestion, the digestion on which polymer, carbo or protein or lipid, and the condition of its digestion from pH, okay, and if enzyme here, you have to know the name of this enzyme to work in this position. First, digestion in mouth, or as we see, buccal digestion. So mouth or buccal digestion mean the digestion inside the mouth. Okay, inside your mouth, 3 parts. First one, teeth, and teeth divided into incisors, canines, and last one, premolars and molars. Incisors help in cutting food. Canines tearing food. Premolars and molars help in cut food into small pieces and grind them well to ease the second step in digestion. Number 2, tongue. Tongue, its function here is manipulate the food with saliva. So the function of tongue, manipulate the food with saliva or mix the food with saliva. Number 3, saliva. Saliva, okay, it's liquid, fluid inside your mouth, okay, consists of 1, water, number 2, mucus, number 3, enzyme. This enzyme is named by ptyalin or amylase. Water is about 90% of total saliva. Mucus for moisture, so your mouth always moist. Enzyme ptyalin or amylase. Ptyalin or amylase or saliva is all secreted, produced from salivary gland. Okay, we have three pairs of salivary glands inside your mouth. We have three pairs of salivary glands secrete saliva. Now I want you to know the pH inside your mouth. pH inside your mouth is from 7.5 to 8, so it's alkaline. Okay, so the pH inside your mouth is alkaline. Ptyalin is an enzyme, so it works in pH 7.5 to 8, so the optimum medium here is alkaline medium. Ptyalin, its polymer is carbohydrates. Carbohydrates polymer, so the type of polymer that you get from food is starch. By ptyalin, starch will be changed into maltose. Maltose is a disaccharide. So the digestion here not completely completed. Okay, completed. So digestion here, this is the only first step in digestion. Number 2, pharynx. And pharynx is a cavity. Is a cavity shared between respiratory system and digestive system. Respiratory system, the following part of pharynx is trachea, and digestive system is esophagus. And we are here in the system, so we will change to the next step, esophagus. Number 3, esophagus. Esophagus is a tube that link between the rear portion of the cavity, pharynx, to stomach at the last of this tube. This tube is its length about 25 centimeter, okay, and is lined with muscle, okay. This muscle, its rule, contraction and relaxation for what? Yes, to push the bulk of food, okay, push the bulk of food during the esophagus, okay, and the way of this movement as this shape. So the food will move through as this shape. This is the bulk, so here contraction. After a while, the bulk will change its position, and this part without swelling is a relaxation. The group of contraction and relaxation is named by peristalsis. So the peristalsis is a group of contraction and relaxation of the esophagus muscle to move the bulk of food from mouth to stomach. This is esophagus. Very important point here. How can you know the rule or the path of food if not get inside the trachea instead of getting inside the esophagus? In trachea, the first part of trachea is epiglottis. Okay, this epiglottis is a skin excess present above the trachea, and air opening, okay, named by glottis. During passage of food, okay, the trachea and the larynx, you know larynx is the voice box, okay, elevate upward, okay, in front of the epiglottis. So the trachea will closed by the epiglottis, and the only tube, okay, be open is esophagus. So this is a mechanism of transportation of food from mouth to esophagus to stomach. Number 2, in digestion, stomach or gastric, same in meaning, digestion. Stomach or gastric digestion. Stomach at this shape consists of muscles and 2 opens, okay. First open, the upper one, is a cardiac sphincter, and the last one pyloric sphincter, meaning of cardiac toward the heart, pyloric meaning toward of the liver. Okay, and we have here muscles. So stomach is a muscular sac. Okay. The type of digestion inside here, according to the juice of stomach or gastric juice. Gastric juice, number 1, water, about 90% of total. Number 2, we have here HCl, hydrochloric acid, okay, and its pH about from 1.5 to 2.5, so it's conc HCl. Number 3, we have here a different enzyme, pepsin. Pepsin enzyme, its pH is from 1.5 to 2.5. Okay, now I want you to know the rule of each one in the gastric juice. Well, first one, water. Okay, water is very important for metabolism. Number 2, HCl. HCl change the pH from alkaline to acidic. Okay, and pepsin enzyme work on second polymer here is protein, and its digestion is also incompletely into polypeptide. So digest food into polypeptide, okay, incompletely. Okay, we have here 2 questions. First one, pepsin digest protein, and the stomach also from protein. So it cannot digest protein of the stomach because pepsin not secreted in pepsin but secreted in pepsinogen. Pepsinogen is the second phase of pepsin but inactive. After activation by HCl, turn to pepsin and then work on protein and digest protein into polypeptide. Also, to protect the stomach from the effect of HCl, secrete mucus. Mucus is a protective layer. So the stomach protects itself by 2 H's. First one, mucus. Second one, pepsinogen that is inactive and be activated inside the cavity of the stomach. After the food, after treatment, will transfer to number 3, small intestine. Small intestine is divided into two parts. First part is duodenum. Second part is ileum. Okay. This is very important. Please focus here. Duodenum. Okay. Duodenum is the first part of the small intestine. Okay, and we have here two accessory glands that observe on this part. First one, liver. Number two, pancreas. So we have here two types of digestion. First one, liver. Second one, pancreas. And the third one, the intestinal digestion is named. First one, liver, and the liver not a digestive organ or not help in digestion, but secrete bile juice. So the liver secrete bile juice and keep it inside gallbladder like this shape. This is the liver, and inside it a gallbladder. Gallbladder is the part of storage. After a while it will be secreted over the duodenum. Okay, so this is a gallbladder, okay, and secrete bile juice. Bile juice, it is not a digestive enzyme, but bile juice only help in what? Emulsified meaning turn lipids to emulsion, okay, like oil inside water. So it turn only into small fragments, not digest, okay. Emulsified fats or lipids into emulsion, okay, so turn into emulsion. So this is the rule of liver. Number two, pancreas. Pancreas, okay, a lot of enzymes here. First one, the medium here not alkaline, not acid. So to turn them into alkaline medium, have to change it by sodium bicarbonate. Sodium bicarbonate is one not enzyme but a mineral that secreted from the pancreas to change the medium into alkaline. Number two, we have here lipase. Lipase is completely a type of enzyme that completely digests the lipids, work on lipids into fatty acids plus glycerol. Number three, from the pancreatic digestion or pancreatic juice. Number three, we have here amylase. Amylase, like in mouse, this amylase share in digestion of starch, but not starch only, and the glycogen. And this is very important part between the difference between digestion in mouse and digestion in pancreas. Amylase digests starch and the glycogen also into maltose. The last one, number four, trypsin, and the trypsin, okay, like pepsin, but work in alkaline medium. Trypsin also secreted in trypsinogen. Trypsinogen is inactive and be activated by, please focus here, enterokinase. Enterokinase, not a digestive enzyme, but only activate trypsinogen into trypsin. Trypsin work on a protein and digest the protein into polypeptide. Okay. The last one, digestion into intestine or intestinal digestion. Intestinal digestion, complete the digestion. Okay, first one, lipase, complete digestion of lipids. So we have here two polymers not completed yet. First one, sugar, and sugar completed by different types like sucrase enzyme, which work on sucrose divided into glucose and fructose. Number two, we have maltase enzyme. Maltase enzyme work on maltose sugar and digesting them in glucose and glucose, two molecules of glucose. And third one here is lactose, milk sugar, and lactase is enzyme, lactose the sugar, and divided into glucose and galactose. Okay. Still here protein, okay, not digested completely. So here we have the last enzyme, peptidase. Peptidase enzyme, not one enzyme but group of enzymes that work on protein and change them, digest them into amino acids. Okay, this is complete digestion. After a while, after digestion, we have the second step. What? Absorption. Okay, how the body can get benefit from those monomers, amino acids, monosaccharides, and fatty acids or glycerols. Okay, we have here a very important part inside the small intestine. This is named by microvilli. Microvilli, okay, inside small intestine and differentiated into a huge number of microvilli to increase surface for absorption. Each microvilli consists of micro, small part also, microvillus. Okay, so we have here microvilli, microvillus, and each microvillus consists of two types of blood vessels. First one of blood vessels is a lacteal vessel, and lacteal vessel depend or related to immune system, and the type of liquid here is the lymph, while the another one is a route of blood, okay, artery and vein. Artery and vein, so the liquid here is blood. So we have here two routes inside the small intestine. First one lymph, second one blood. Okay, which one of those will carry each one of the monomers? You will see. Blood route. Blood route, okay, please focus, amino acids, monosaccharides, and vitamins. But which vitamins? Vitamins that dissolved in water, minerals, okay, and push them to liver. So the next step is liver. Liver, the vein that get inside liver is a hepatic portal vein, and after a while the excess sugar will turn into glycogen, and amino acids will change to urea and expel out, and the rest of the monomers will get out from the liver by hepatic vein. Then we'll go to the heart. Heart, you know, letter consists of 4 chambers, and pore, it's contained, okay, in vena cava. Vena cava is a vein that pour its component inside the right side, right atrium of the heart, okay? So it collect and go vena cava, in which part? Inferior vena cava, meaning of inferior, that collect blood from the downside parts from the body. So this is a blood route. Lymphatic route. Lymphatic route, okay, contains, please focus, lipids, fatty acids, plus glycerol and vitamins, but not vitamins, the vitamins that dissolve in lipids like K, E, D, and A, كده. Okay, so we have 4 vitamins that dissolve in lipids, K, A, D, and A. Okay, after, by transportation of those components, will also get to heart, but now into superior vena cava. Superior vena cava, pour inside the heart. For your information, okay, not all lipids transported by the lymphatic route. Maybe some of fatty acids and the glycerol recombine, okay, and transform again to fats, and the fats stored under skin. So not all fatty acids and the glycerol can transfer through the lymphatic route, but also can back to its origin shape, fats, and stored inside, under skin and surrounding of the organs. The last step in the digestive system, okay, we have the large intestine. Large intestine, okay, its mission to move the wastes from the small intestine that get out from the digestion to get out. So this wastes contains a huge amount of water, and body cannot get this amount of water out. So first one, reabsorption, okay, so first one, water will be reabsorption. Number 2, and wastes will be deal or treated with the type of benefit bacteria. This bacteria, okay, responsible for absorption also some of minerals and the vitamins that is very important for the body, and also get the smell or the odor to the wastes. The last one, rectum and anus. Rectum and anus. Rectum, okay, surround with the muscle. Rectum is muscle, and anus also surround with the 2 muscles. Both of them help in push wastes outside of the body. Okay, how? By contraction and relaxation. By contraction of the rectum muscle, this is contract, and relax of the anus muscle, the wastes will push outside of your body. Thank you, and see you again in next video.